Pavel from the Space Engineers, so you know what I will be talking about. Okay, hello. Is it working? Yeah. Okay, thank you. So, today I will be talking about multiplayer challenge that was held in Nevosoft.Ru house, and I was part of it along with my colleagues Petr, that is here, and Sandra. So let me first introduce our company. We are Nevosoft.Ru house. We are founded in 2010 by Marek Rossa. We have about 50 plus developers, and we are still privately held company, so no like money from outside, it's just from games that we made or the company made. Our games were Minor Wars in the past, and now we are operating 2 games still in early access on Steam, Space Engineers and Medieval Engineers. So Space Engineers, they are, at the moment, there are 3 years in Steam early access. There is 2 million plus players, 200,000 mods on Steam Workshop. It's actually the biggest, or one of the biggest workshops on Steam. And we have our own engine for the game, which is called VRage, which is written in C#, although with some parts in C++ as well. And we use DirectX 11, Havok physics, etc. So the game is a sandbox game. It has infinite playground. We don't have any boundaries there, so you can fly around in space. We have editable and destructible environment, so there is nothing like levels or something like this. Anything that you are playing in, you can build yourself or destruct yourself. Along with some system of grids, we have voxel system that is used for asteroids and even planets, which can be like 100 kilometers in diameter. And we have 2 modes, survival and creative. And of course we have multiplayer as well. So, this is how the game looks. This is actually some alien planet. This is Mars and some base near the orbit, or on the orbit. This is some drilling, so the part survival is of course about gathering all the resources and drilling them from the asteroids, etc., or from the planets themselves, so you can actually make holes in any planet or asteroid, and you can drill it completely. So this is some based on the planet that is being crafted right now, so it's built. using the resources in the survival, and this is some battle. So, Keen is known for space engineers, of course, and not only for that, the King was also known for really bad multiplayer for some time. So, although we have quite good reviews on Steam, the multiplayer was received very badly. So what Marek Rosa did about half a year ago, he proposed a challenge in the company that whoever wants to can join, and he will get 3 months to make a new multiplayer, essentially rewrite the game's multiplayer logic. And the reward was 1 million crowns. So we joined it, or actually two teams joined the competition, and now I skipped the part where we are hardly working for 3 months, and it was really lots of work, and I will get to that, definitely. It will be actually the raw meat of this presentation. The game was, or the new multiplayer was released before this Christmas, or the last Christmas, to the overwhelming reaction of the community, because they were really striving for something like this. So, our team what was the development cycle of our team? We were, of course, we weren't like really skilled multiplayer engineers or something, so we started off by just playtesting the current multiplayer. So we are playing a lot. We are like testing the game, writing ideas, what's really like working poorly. The second part, when we were idea what's like from player perspective really wrong. The second part was about integrating the debug tools, so we could actually find out why it's working wrong, right? Because it's what's working wrong and why it's working wrong. And then we were actually experimenting how to make things better. So we were creating some hacky implementations of various ideas on branches, so just quickly hack together, playtest, and and then of course talking about it and having honest feedback, which is in development very, very important. So even though you like your colleagues, you still have to give them honest feedback. Sometimes, of course, you don't want to give feedback too early when you are not sure, because otherwise you can kill the good idea. So it was like a lot about balancing these. But definitely the wrong paths were abandoned without mercy. So we had lots of experiments that we had to scrap. And that was nearly it. Like actual coding was more like removing lots of bad code that was there already in Space Engineers. And we spent like the least time of actual final coding the final code in the game. We actually removed more code than we added. And now I will talk more about what we, how the development process was, like what we were doing actually. So first, let me talk about the debug tools that we implemented, so we can actually find out what's working wrong. So first was the statistics tools. Statistics are great, but of course, in most games, the statistics are just the numbers. You can see them like changing on the debug screen. What we used for this is like time-based statistic. So not only we had like real numbers, we also had some progression along the time, which really helped with the spikes or with some strange behavior that you cannot grasp just from the numbers. So I can definitely recommend this. We also implemented Profiler because multiplayer server client is about having the good performance. When your server is unable to contain the load of the clients, then the game is poor as well. So we implemented profiler that works not only on client that is running the profiler, but is able also to see the data from the server. Although the server doesn't have any visual screen or something, we could stream the data to the client and see the profiling data, which was also essential. And we could also save and load them to the file, which was the easy part, of course, when we had the serialization already, and use them for analysis later. And for example, we can use it for community when they have some good performance, that they can send us the data for analysis. So this is how the profiler looks. It was already in the game before. We added just this client server possibilities to that, and it helped a lot with the profiling. So then we used the debug screens, because which is also quite standard thing in the games, to kind of tweak all the values in the game. What's not probably that obvious is that in multiplayer, when you are doing some kind of synchronization of entities, there is lots of magic going on the network that you have completely out of control. The packets are flying around, they get lost, they get out of order or whatever. So getting the entities displayed at the right positions at the right time is kind of tricky to have the game responsible as well. So this part is actually a lot about tweaking various responses of the objects, of the interpolations, and so the game for the player is perceived as responsive and fluent. So it was quite important to have those to have possibility to tweak those values to some in real environment while playing. So then we of course used some tool to simulate bad network, because of course we were in the office, we had our computers networked using LAN. So in this environment it works, everything works perfect, of course. But once you will get some lag, it gets worse. And once you get some really nasty things in, like packet drops out of order, duplicating packets, it can get much worse. Your entities start lagging, or even the server can start crashing. So those were the settings for the networking. We actually use, for the most part, 500 milliseconds lag, which is quite crazy. You mostly don't want to play game in such an environment, but it also shows the errors or the problems much more, so you can then, or we could then like tweak it better or find out the errors better. So then we used, of course, physics remote debugging, which is pretty standard thing when you are doing physics game, to have some like visual cue of your physics environment. But in our case, we used it, or we tweaked it, so it's possible to connect it also to the dedicated server and see actual objects on the dedicated server and debug the real environment. Because sometimes, of course, on the client you see just the things that server tells you. Sometimes you don't see some things. So this way we were able to somehow see even things that server didn't tell us or did tell us wrongly. And we used spectator camera a lot, which in our case it's like, of course, again, standard thing in games. In our case, we have like two very nice features. Like one thing is that using mouse wheel we can change the speed of the spectator, so we can very quickly get to any location in the world, and then we can also attach to the speed of some object. So then we actually rate the speed, the velocity of the object, and change the velocity of the spectator, and then we move around this velocity. So this way, as the spectator is not synchronized using network, the velocity of the spectator is fixed, but the object's velocity is synchronized with the network. So this way we can kind of find out whether the object is lagging, whether it's somehow jittering or whatever, because we know that visual cue of the camera is set. It's a fixed velocity. So this also helps us. Tracing. Although we use Visual Studio, we found out, or probably you know as well, that output window of Visual Studio writing to console is very slow. So I really recommend this tool because it offloads your, like you can trace whatever hell you want to, like thousands messages per tick. Still, it can still handle it. Just one warning, it's using TCP/IP or some form of protocol, and in connection with clumsy, it gets like it has a little bit problems. So if you will throttle down the network, you have to throttle it properly just on the specific IP addresses, otherwise you will throttle the tracing as well. So what we learned using those debug tools. Sorry. The worst thing probably was that clients in the old multiple. Okay, so that was fast. So we got through debug tools. I'm about at the middle of the presentation and I have to stop. So maybe next time. Okay, so I can just quickly go through what we learned. We learned that clients were telling server what to do, which is of course bad. There was no lag compensation in the game, and the time synchronization were used. So when, for example, server is slow or client was slow, the time synchronization was using altering velocities of the physics objects, which was really pain to maintain. So, and of course performance problems regarding the linear complexity of the synchronization of the world. So what we changed was making the server authoritative, so it really just client tells him what controls were pressed, and clients and server simulates everything and just sends the results. Physics-based prediction. So although client sends the controls to the server, it also simulates them meanwhile, so it's completely responsive even when there is a really huge lag. And when server tells the client the new coordinates, it applies it in the history, because it's connected to, of course, old position that was there, like for example 100 milliseconds in the past. Then we synchronize simulation steps, so client and server are always have the same amount of simulation steps, timestamps are the same, so physics were always in sync, so we knew that when the packet went to server and back, that we went through certain amount of ticks, and it can be applied to this on the client, the new positions. And we change, we optimize the algorithms that were synchronizing objects to the clients. So it was using some tree going through the entities, and it wasn't synchronizing the whole world, just the surroundings of the player. And in the future we also plan on the servers simulating just the parts that the players are in, not just the whole world. So it will help also with the server performance. And we added some admin tools that were helping with cutting down the amounts of objects in the world.